All right, welcome back. Statics, yay! Okay, this is also out of your textbook, 5-65. And here, I've described it. Remember, in your given find solution format, I ask you to look at a picture and describe in your own words what you see. So this is my description. A student attempts to hold himself in two different ways. And then I've given some knowns. We were given these in the problem. And the question is, how much force must he exert on bar AB in each case? So this is a machine, and he's part of it, or she. It's a guy, so he's part of it. And it's a machine with pulleys and a platform and a bar and even a person. So what do? We take them apart, explode everything out, and start drawing free body diagrams. So let's do case A. So for case A, I'm going to start with a free body diagram of the platform. So there's the platform. And it has a weight on it going down. And the person has a weight and the platform has a weight. So this is actually the weight of man, as I've called it here, plus the weight of platform, plat. And looking at what's happening is this man is standing on the platform and he's pushing up against the bar, and that's causing his normal force to push down on the platform. So we have a normal force here going down, a reaction force of the man on the platform. And we have tension in these cables, and everything's symmetrical, so I'll just call those T and put them on both sides. So summating forces in the y direction equal to 0. Let's do that. Then we have 2t minus n minus w man minus w platform equal to 0. And that's all we can do. Now let's move on up the line. Now the next thing is these tensions go up and attach to a pulley. So let's draw the free body diagram of the pulleys. Call this pulley A, call this pulley B. Then we have the tension going down, T equal, I'm sorry again for that going off screen, but that's all it is a pulley, and then this T going up to pulley A, putting that in tension, and again this T going to pulley B is that. Now looking at pulley B, pulley A, we do a cut around here. We've got these two tensions going up. So let's draw them as well. Let's call them, they're not T, let's call them T1. And summating forces in the y direction equal to 0. We have, well, you can just do one of these. These are symmetrical. So let's just do just do one of them to get our equation. We have 2t1, let's just say about pulley A. 2t1 minus t equals 0. All right, cool. So let's move on to the next item in the link of forces is this T1 goes up and this T1 goes up and attaches to that bar. So let's do a free body diagram of that bar. Bar A, B. So we got a tension on either end of the bar. That's T1 going down. Where is it? There it is. T1 going down. And then you have, he's got, so this man is pushing up on that bar. And so you got a force going here and a force going here. So basically, this is a component force, half the component force here and half the component force here, and together the resultant force is just F going up. Half of it in each arm. But we'll just take the resultant and put F right in the middle of that. Just say F. That's the force. Just call it F. Like that. So summating forces, y equal to 0, you see that F minus 2T1 equals 0. So 3 equations. Let's see what we got. That's a known, that's a known. N is an unknown. Aha! Look at N. Let's do a free body diagram of the person. We're going to need that. So here's the person, and they got their arms. Well, the arms are going up, it's true. All right, so there's a sketch of the person. And we've resolved half the force in this hand and half the force in this hand. So we have a force going up, and we have an N going down. Summating forces y equal to 0. Force minus N equals 0. So here we can say that force is equal to N. And here we can say that 2T1 is equal to T. Here we can say that 2T1 is equal to F. And substitute all that back in to this equation and solve. So let's do that. So 2T so T, we said, T is equal to 2T1. 2T1 is equal to F. Aha! So F, T is equal to F. So T is equal to F. So here we can say 2F minus, we said N is equal to F, minus F, minus the weight of the man is 175, and the weight of the platform is 30, equals 0. 1F is equal to 205 pounds. So that's the answer in case A. He's got to push up with 205 pounds. Barely sustainable. I couldn't do it. All right, we'll take case B next.